So we are going to look at textbook page 430, question number 6. A jet skier leaves a dock at 8 a.m. and travels due west at 36 kilometers per hour. A second jet skier leaves the same dock 10 minutes later and travels due south at 44 kilometers an hour. At what time of day to the nearest minute will the two jet skis be for 20 kilometers apart? So this is an example where we're going to create a right triangle. We have an object traveling west. So west and traveling south. When they're at west and south are perpendicular to each other. And so we want to know when they are 20 kilometers apart. So we're working with displacement. Remember, speed is equal to displacement or distance divided by time, and distance is equal to the velocity times the time. Now, we are given velocities, and we need to determine how we're going to figure out the time. So what we have to do is say that t is, and we have to choose either the first jet skier or the second jet skier. Doesn't matter. Let's choose the second jet skier. So it's the time the second jet skier travels. And so we know that to get the displacement here, we're going to take 44 kilometers times whatever time it is. We don't know what time it is, but it's 44 times that time. And then because the jet skier left the dock 10 minutes later, we know that the first jet skier, t plus 10 out of 60, and I'll talk about the out of 60 for a minute now. 10 out of 60, or t plus 10 divided by 60, that's the 10 minutes later. T is in hours, and so we're converting the 10 minutes into hours. And I'm just going to reduce that. T is equal to, T plus 1 out of 6 is equal to the time of the first jet skier. So we have his speed, or her speed, at 36 kilometers an hour times the time, which is t plus 1 out of 6. We know that this is a right angle, so we can use Pythagorean theorem, where the longest side, or the hypotenuse, 20 centimeters, or 20 kilometers, when we square that, that will equal to one side, so 44t all squared, plus the other side squared, 36t plus 1 out of 6 all squared. And let's simplify. That gives us 400 equals 44 squared. Let me just pull up my calculator here. 44, oops, let's out of the graph. 44 squared. That's equal to 1936, so 1936 t plus, and I'm going to simplify this first. So inside of this, we get 36t plus 6, and that's because 36 times 1 over 6 gives us 6. And now we're going to square that. 36 squared actually, I'm going to leave that exactly how it is, and we're going to solve using graphing, but another technique for graphing. Just move my graph over here, calculator over there. I can do my y1 is equal to 400 and y2 is equal to 1936. 1936t plus 36t plus 6 squared. So let's graph those. I'll clear out the graph I had previously. So we have 400. Oops, that's not what I meant to do. So let's go back into the y equals. We want to go down, and we enter 1936 times t, or x on the calculator, plus 36t plus 6, close that, and then square on the outside. I am looking for the intersection of these two. So I'm going to go zoom, and if I scroll down here, it's zoom and fit, so 0. I should see there's one of my horizontal line, that's the 400, and going down and coming up. So let's look, expand my window, and I'm going to go, I'm going to just change the Y. I don't need to go quite that high. How about I go up to 1,000? And let's see what the graph looks like. Okay, so something's funky happening. I'm going to pause and I will correct this on the calculator. Okay, so I found a couple of mistakes in my entering onto the calculator. First of all, I had put, instead of 1,000, I had 100. So when I graph this now, it looks better. I also have extended, I went from -5 to 5. Just changed the windows a little bit, so I'll go back to the window pane so you can see the window settings. The other error I made, and I did it twice, I squared 44t, but when I wrote it down, I squared the numerical value, but I did not square here. So that should be t squared. This should be t squared. So when I put it onto my calculator, I need to have a square in here. So right there, I go second and delete, which gives me the opportunity to insert, and I'm going to insert my square. Now my window settings may be incorrect. I need to graph. There's my 400. And let's see where, and it's still there. Okay, so we can still see it. So notice that negative, that would be a negative time. We're not going to worry about that intersection point. It's just this positive intersection point over here. So I'm going to go second and trace. I want the intersection point, which is 5. So enter for the first equation, enter to say this yes to the second, and then we're going to get it to calculate, and it gives us an intersection point with the x of 0.27535. So let me write that down. Just move the calculator off to the side here. So we have a t value of 0.27535 seconds, or no, sorry, hours. And so that's how long the second jet ski travels. Remember, the time for the first jet ski is 0.27535 plus 10 minutes. Well, we have to turn that into hours, so that's 60 out of 10, so 1/6. So let's go over here, and we take 0.27535. Oops, I missed the 2 in front. Plus 1/6. And we can't have 2 decimal places, so let's delete that second decimal place. Oh, right, here we go. And so the time for the first boat is 40.442 of an hour. But we're being asked what time of day to the nearest minute, and so I'm going to multiply this by 60. And so they travel for 26, 27 minutes, the first jet ski. He leaves at 8 a.m., so it's going to be 8:27 a.m. when they're at the same distance. And now, just if we want to check this, we can do that by looking at our triangle. So we know that this displacement is 36 times, let me bring the calculator up, 0.442016, 0.442067, and this is 44 times, and we'll bring the calculator up again, it's 0.27353, and that's equal to 200, or 2. So we can check that by taking this value and squaring it. So I take 36 times 0.442016, and that gives me 15.9. So I'm just going to record this. 15.9 is my displacement here. And then we take 44 kilometers an hour times 0.27353, or is it 5? Yeah. And this is 12. So if I have 16 squared, I'm just rounding that, plus 12 squared, does that equal 400? Well, 20 squared, or 400. Let's see. So I take 16 square plus 12 squared, and that's 400 exactly. And so we can see that that time is correct.